Welcome back. This is 6.2 triangles. So our objectives are solve problems involving angle relationship in triangles, solve problems involving similar triangles, and solve problems using the Pythagorean theorem. So a closed geometric figure that has three sides, all of which lie on a flat surface or plane. So closed geometric figures, if you start at any point and trace along the sides, you end up at the starting point. So that's our definition of a triangle. All right, Euclid's theorem. So it says a conclusion that is proved to be true through deductive reasoning. So that's what a theorem is. So Euclid's assumption about parallel lines. So it says given a line and a point not on the line, one and only one line can be drawn through the given point parallel to the given line. So we have our two lines, and then we can draw the intersecting lines to get our triangle. So angles of a triangle measure up to 180. All right, so it says find the measure of angle A for the triangle ABC. So remember, they all add up to be 180. So we would have 180 minus 120 minus 17. Or you can do it 180 minus, and then you add those two together. So it'd be 180 minus 137. And that is going to give us 43. So that's the measure of angle A. All right, so then it says find the measures of angles 1 through 5. So we know right here, this square means it's 90 degrees. And then angle 1 is supplementary to that. So you do 180 minus 90, which is 90 degrees. So anytime you have a 90-degree angle and a line like this, that other opposite angle on the other side is also going to be 90 degrees. So the measure of angle 1 is 90 degrees. So then we have 90 right here, so I'm just going to erase this. So this is 90. So then we have 43, and then we want to find out what angle 2 is. So we would subtract those from 180. So 90 plus 43. So we get 180 minus 133. So that's going to give us 47. So the measure of angle 2 is 47 degrees. All right, so this is 47. So then remember our rule with vertical angles. Those are similar. So the measure of angle 3 is also 47 degrees. And then we have the 60, so we just need to find 4. So 180 minus 160 plus 47. So that would be not 160. So that would be 107, which is going to equal 73 degrees. All right. So that is a measure of angle 4 is 73 degrees. All right. Now we can use what we know about these two angles, that so 4 plus 5 is going to equal 180. So we can do 180 minus 73 would give us 107. Because we kind of already did that already right here at this step. Let's write it out. So the measure of angle 5 is 107 degrees. All right, triangles and their characteristics. So we have acute, right, obtuse, isosceles, equilateral, and scalene. So if you want to read through those, go ahead and pause, and you can read those definitions. All right, similar triangles. So similar triangles have the same shape, but not necessarily the same size. In similar triangles, the angles are equal, but the sides may or may not be the same length. Corresponding angles are angles that have the same measure in two triangles, and corresponding sides are the sides opposite the corresponding angles. So the triangles ABC and DEF are similar. So they have corresponding angles and sides. So our corresponding angles are A and D, C and F, and B and E. And our corresponding sides are AC and DF, and AB and DE, and CB and FE. All right, using similar triangles, so finding the missing length, because the triangles are similar, their corresponding sides are proportional. So that means you're going to be using fractions for these. So it says 5/8 is equal to 7 over x. So that means these are corresponding. So that 5 over 8. So that means the corresponding side over here is that 7 and x, so 7 over x. So we're going to multiply each side by x. So we have x times 5 over 8 equals 7. Then we can times by reciprocal to get rid of our fraction. So we have x equals, so 7 times 8 is 56 over 5. So it doesn't say if we're rounding, but if we're rounding, it would be 11.2. So 11.2 inches. Because usually if you have like measurements, you want them in decimals, not necessarily in fractions. All right, the Pythagorean Theorem. So the sum of the squares of the lengths of the legs of a right triangle equal the square length of the hypotenuse. So if the legs have lengths A and B, and the hypotenuse has length C, then A squared plus B squared equals C squared. So you should know this, but if you don't, just know that you have your two legs, they'll equal that, the square of the two legs will equal C. So you'll notice the area. So if you added these two together, so 16 plus 9, you would get 25 square units. And that's the same as that length C. All right, so let's try one. So we have A and B, and then we want to find out what C is. So we have 9 squared plus 12 squared equals C squared. So 9 squared is 81. 12 squared is 144. Now you can square root at this stage, or you can add those together and then square root it. So if you added those together, you would get 225. And then you can square root it. It's up to you. Either way, you'll get that same answer. So 225 square rooted is going to be 15. So C is going to equal 15 feet. Because you want to keep those same units with whatever your example is giving you or problem on your homework is giving you. All right, that is it for 6.2. Let me know if you have any questions. Otherwise, go work on your assignment.